for equitable. Hi, and welcome to my presentation on remote sensing for equitable development, predicting crop modal price volatility using normalized difference vegetation index and road network centrality measures. Now, that's a lot to unpack, and we'll be unpacking most of those terms as the presentation goes on. Our story begins in Kalikiri, which is a small district in Andhra Pradesh. It's also home to Raj Reddy, the 94 winner of the Turing Award. We focus primarily on the villages in and around Kalikiri. These are characterized by extremely small size, less than 4 acres as compared to 450 acres, the average American farm size. And really want to ask ourselves, can we predict a price shock 90 days before it occurs using just satellite data? And why do we use just satellite data? Is because it's cheap and it offers a comprehensive bird's eye view of what's going on the ground, and it's very easy to distribute and democratize amongst farmers. Here we look at our primary data source, which is basically the NDVI. The NDVI is nothing but a ratio of energies between two spectrums. What this basically allows us to do is it allows us to tell when the fruit is at its ripest. So it goes to 1 when there's a lot of vegetation, and it goes to 0 when there's comparatively less vegetation. This allows us to approximate a curve called the phenological curve, and the phenological curve needs to be measured on the ground. You can see it's measured in grams per day. But the NDVI allows us to measure this without actually being on the ground. Here's the NDVI for the Kalikiri grid that we saw on the first slide. As you can see, it's very dark for a lot of vegetation and very light for less vegetation. The second part of our analysis is connectivity, and we use graph theory to assess the importance of the nodes of this road network, and then we extrapolate that to all the grids that surround this road network, and we sort of fill it in. And here we have hot for very important grids and cold for less important grids. And we bring these both together in something called the summed NDVI. Now the summed NDVI is basically the importance of the grid multiplied by the NDVI of that grid. As you can see, the curves generally looks like the phenological curve, but now it's weighed by the importance of each grid. This is our Y variable, which is the mandi price, and here, as you can see, it is very noisy. And there's really not much more to say other than the fact that it was scraped from a government website. And now we bring the two together in a linear model, and the reason we do that is because we want to check if there is indeed a relationship between the two. And it turns out to be that yes, there is a relationship that is significant at the 1% level. So then we go ahead and fit a machine learning model, the decision tree, and present the results. So here you can see that the decision tree performs very well at picking out these peaks and troughs, but the linear model is reasonably better at approximating the general fluctuations in the price. So that means yes, there is a relationship. Now, if you recall, our original research question was actually to predict the price shock, and the previous analysis allowed us to know that there is a relationship. So can we actually go ahead and predict a price shock itself? And so we run a peak detector and we check based on our train and test sets whether we can build a classifier that can classify peaks. So here's the performance on the train set. As you can see, it's done quite well on learning some of the peaks. Let's go ahead and see what it looks like on the test set. On the test set, again, it does reasonably well. It's picked out the two main peaks in the test set, but it's also given us two false alarms, which I guess is reasonable given the model structure so far. And so where does this leave us? So what we've done here is we've created a model that predicts price shocks based solely on satellite data. And that's important because it gives a very cheap, easy data set that can be distributed to farmers and allows them to enhance their productivity. Now remember, all of this takes place in the backdrop of the farmers' protests in India, which are primarily because marginal farmers are simply not able to compete with the larger farms, and they really depend on government aid. We hope that our algorithm will go a long way in remedying some of those issues. Thank you.